Good day to all of you. Today we shall discuss on the question number 7a from model question paper set 1 of the subject Digital Design and Computer Organization with the subject code BCS 302. So question number 7a is as follows. Explain memory mapped IO and IO interface for an input device with a diagram. So this is asked for 10 marks. This is the diagram that we should know for this answer, but it belongs to second part of the question, that is IO interface for an input device. The first part deals with memory mapped IO. So first we shall answer what is memory mapped IO, then we shall come to this question, IO interface for an input device. Okay. So this diagram, if we refer, this shows the single bus structure, means how the different parts of a computer are connected through a single bus. The connecting lines which connect the different parts of a computer, that is called as bus. The different parts of computer are processor, memory, IO device 1, IO device 2 till IO device n. IO device in the sense input device and output device. There will be n number of IO devices connected to the bus of computer, that is system bus of the computer. Input device example, keyboard, mouse, joystick, and output device example, printer, plotter, display device, that is monitor, and so on. Okay. So here the processor does arithmetic and logical operations. So it has ALU unit and one more unit, control unit. The control unit sends the control signals to all different parts to coordinate and control the activities of different parts of the computer. When processor can do the task of arithmetic and logical operations, the data must be given by the user and instruction also. That is, the program and data is given by the user. That is entered by input device keyboard. Over the bus it is passed and it will be saved in memory, our data and program. From here, from memory over the bus, it is given to processor for execution. After execution, what result is obtained by the processor over the bus, it is sent to memory for storage, or it can be sent to output device for the display or any other interpretation which the human being can understand. So this is what is a single bus structure of a computer, wherein different parts of computer are shown. Here, then what is memory mapped IO? Memory mapped IO means there are two kinds of communicating the processor with the IO devices. The first kind is memory mapped IO. Another one is IO mapped IO. In memory mapped IO, the memory location store the address of input and output devices. So if processor wants to communicate with these input output devices, it sends the address on the address bits to the particular memory location where address of IO device is stored. Then over control lines, it sends the command or control bits. So this bus will be having three sets of lines: data lines, address lines, and control lines. On address lines, processor sends the address of that memory location where IO device address is stored, and over control lines it sends command or control bits as to specify to that memory location or to that IO device connected to that memory location whether processor wants read operation or write operation. When read operation, that IO device will give the data and processor will read that data. When a processor wants write operation, it sends the data over data lines to that memory location where IO device is connected. So what memory space, address space. So memory address space is there. There only IO addresses are stored or IO devices are connected, and that kind of communication between processor and IO devices is called as memory mapped IO. In IO mapped IO, every IO device will have IO interface. In that, one address decoder will be there. Processor, whichever IO device wants to communicate, it puts the address bits on the address lines. that will reach all the interfaces, means interfaces of all the device. In that address decoder, when it resolves the given address, when it decodes, if it matches with that particular IO device, that IO device will respond and the remaining IO device will not respond. In that IO mapped IO, the processor doesn't communicate with memory, but it communicates directly with IO devices. So special kind of input output instructions will be used in IO mapped IO. In memory mapped IO, what memory related instructions are there for read and write? Same instructions are used. But in IO mapped IO, special instructions like in, out, they will be used. Okay, so that is what is memory mapped IO. So solution, what we can write: when IO devices and memory share the same address space, the arrangement is called memory mapped IO. With memory mapped IO, any machine instruction that can access memory can be used to transfer data to or from an IO device. If data in is the address of the input buffer means it's memory associated with the keyboard, the instruction move data in, R0 reads the data from data in and stores them into processor register R0. So what is happening here? Move data in R0. This is source, this is destination. Move copies the content from source to destination. So if data in is the address of input buffer associated with keyboard, so the memory location which is related to keyboard, its name is data in. Then the instruction move data in, R0 reads the data from data in, that is keyboard pressed character it is, and stores them into processor register R0. So keyboard pressed character, that is from data in, it is copied to R0. So this is the instruction in memory mapped IO. This is for reading. Similarly, the instruction move R0, data out sends the content of register R0. So keyboard read character was kept in register R0. This is the register of processor. Processor will be having n number of register, R0, R1, R2 till Rn. Then some special kind of registers also. This is general purpose register. Move R0, data out sends the contents of this register R0 to location data out, which may be the output data buffer of a display unit or a printer. So buffer means memory. Okay, this memory corresponds to display unit. The read character was kept in R0. So keyboard read character was in the buffer data in because keyboard is connected to this memory. From there it is copied to R0. Then that character is given to buffer data out where display unit is connected. So hence when copied here, it is displayed on the monitor. So these two instructions, memory related instructions, they are used in memory mapped IO for read operation and write operation. It is read from keyboard here, it is written to display unit buffer for display. Okay, that is what is memory mapped IO. This is the answer to first part of question. Next we shall consider the second part of question, IO interface for an input device with the diagram. So this is the diagram of IO interface for an input device. So input device is shown here. This is the system bus. What we discussed, set of data lines, address lines and control lines called bus or system bus, which connects the different parts of a computer, that are processor, memory and IO devices. We are seeing only bus and input device, how it is connected through a special circuit that is called as IO interface. What this IO interface will have? Address decoder, control circuits, data and status registers. Okay, so Actually, what are these registers? What address decoder does? Whenever processor wants to communicate with the IO device, so in IO mapped IO case it sends the address of IO device on the address lines that will reach all IO devices. Here only one is shown, n number of IO devices. Through interface they will be connected to same system bus. So that will reach all IO devices interface. Then in that interface, what address decoder is there? That decodes the given address, and if it belongs to the particular input or output device, then that device will respond to the processor over the bus. The other devices will not respond. So that is what is address decoder. Okay. To control and coordinate the communication between processor and IO devices, control circuits will be there in the IO interface. Apart from these two, we have data and status registers. So what are these data and status registers? That we shall see with another diagram. Okay. Then what are these data and status registers present in the IO interface? Or say input device keyboard, that is input device here. Whenever a keyboard is pressed, that key character will be stored in the data register. Then status register bit for the keyboard will be set. For that will indicate to the processor that the data from keyboard is ready. Then it will read the data through data lines into its register. So the data register holds the data given by keyboard and it will be made available to processor over the data bus. That is in case of input device. In case of output device, processor will send the data to data register of the output device. Suppose if it is output device, that will be interpreted there, either displayed or plotted. So that is what is data register. Status register indicates the status of this IO device, whether it is ready, yes or no. One bit in the status register will be reserved. That bit processor, whatever is connected over the data lines to IO interface, through that to in this device. If that bit is 0, that means device is not ready. If that status bit is 1, then it means that IO device is ready. Then processor over data lines, it will communicate with the IO device. That is what is data register and status register. Okay. So solution, what can be written with respect to figure shown? Now IO interface for an input device. That figure illustrates the hardware required to connect an IO device to the bus. The address decoder enables the device to recognize its address when this address appears on the address lines. The data register holds the data being transferred to or from the processor. The status register contains the information relevant to the operation of the IO device. Both the data and status registers are connected to the data bus and assigned unique addresses. See, what is unique addresses? Different addresses. Because on the same data lines, the data register content and status register content may come. So whether it is data register content or status register content, how to know? The data register and status register are given different unique addresses. So depending upon from which address the bits are coming on data, the processor can make out whether it is the data or status information. This is a very important point. Okay. The address decoder, the data and status registers and the control circuitry required to coordinate IO transfers constitute the device's interface circuit. What is IO devices interface circuit? The IO devices interface circuit is the special circuitry that has address decoder, the data and status registers and control circuitry which are required to coordinate IO transfers, and that is the special circuitry which is called as IO devices interface circuit. Every IO device will be connected to processor over the bus through their own IO interface circuit that will help to control and coordinate the communication between processor and IO devices. Okay, that completes the explanation of second part of the question 7a. So what is question number 7a? Explain memory mapped IO, that is first part, and IO interface for an input device, second part, with the diagram. This is asked for 10 marks. Next we shall discuss question number 7b. Explain IO operations involving a keyboard and display device with a program that reads one line from keyboard, stores it in buffer and echoes it back to display. So this question is therefore 10 marks. It has 3 parts: reading a character from keyboard, then storing it in buffer and sending it back to display. Like this, 3 actions for every character pressed on keyboard by the user, and it should be continued for all the characters till user presses enter button or new line character. So for that we have to take up the program which does these 3 actions and explain the IO operations involved in that. Okay, that is what the question is. So program, that is assembly language program. So as a part of solution, this is assembly language program. Before going to this program, we should have some prior knowledge of the registers in keyboard and display unit. So these are the registers in keyboard and display interfaces. So data in is the register which holds the keyboard pressed character. Data out holds the data given by processor which is being sent to display unit for display. So this is connected to keyboard, this is connected to display unit. So these registers address will be stored in data in and data out memory location. Okay, so data in memory location is connected to keyboard, data out memory location is connected to display unit register. Next, this is the status register which indicates the status of IO devices. SIN, status bit of input device, that is keyboard here. S out, that is the status bit of output device, that is the display unit here. So this is bit 0, that is LSB bit. This is bit 1. So bit 0 is reserved for status information regarding keyboard. This is 0 if keyboard is not ready. This is 1 when keyboard is ready with the data. Whenever user presses a key and the data is ready in data in register here, then processor reads this, means copies this data into its register. So that can do only when SIN bit is 1. That is keyboard is ready with the data in register, right? So processor goes on checking this bit for read operation because input is given through keyboard. If this is 0, keyboard is not ready with the data. Till then processor goes on checking this bit in the status register, that is called as polling. Okay, when this becomes 1, the processor reads the data from this data in register into its own register. Then if that character is to be read from here, it will be taken into R0 register of the processor. From R0 register it will be sent here when display device is ready. That is known to processor by status information, that is of output device, SOut bit, bit 1 of status register. If this is 0, display device is not ready, that is output device is not ready. If it is 1, output device is ready, then processor from R0 register, it puts the pressed key character what it had stored into this register which is connected to data out memory location. Okay, so we can call this as data out register. So this way this status information is used by the processor. And this is control register. Here DEN, display enable, KEN, keyboard enable. These are made by processor 1. If they are 1, then only keyboard and display device can interrupt processor. Otherwise, though they are connected, they cannot be involved in communication with the processor. These are enable bits. This is what is registers in keyboard and display interfaces. With this prior knowledge, we shall discuss the program needed to read a keyboard character, store it in a buffer, then send it to display device for display. So the program which does 3 actions for every character entered by the user through keyboard, and it does these 3 actions for all the characters till the user presses enter button. That is new line character. Means for all those characters 3 actions: reading, storing and displaying. All the actions will be done. That program we shall consider next. Okay. So this is the assembly language program which does keyboard reading, then storing in buffer that character, and then sending that character for display. So the first instruction is move #line, R0. What is the comment here? Initialize memory pointer. Means from keyboard what character is read, in memory where, in which memory location it must be stored. That address, #line means one line of data what is going to be given. This is the starting address of the buffer where line of characters will be stored. That address is copied into R0. Hence R0 register is made as pointer to memory buffer. That is initialized, means starting address of that memory is copied into R0. Move means copy. Copies, this is source, this is destination. #line means this is a number, line, that is the memory location that stores the starting location of buffer. So this hash indicates number, that address value that will be stored in R0. Hence R0 becomes the pointer to buffer where line of characters will be stored. Now here it is at present starting address of that buffer. Hence the comment initialize memory pointer. Second instruction is test bit #0, status. So in status register, #0 means bit 0. So LSB bit that corresponds to SIN. Status information of keyboard it gives. So test that bit, SIN bit. If it is 0, shift the control back to this label. Again come back, the control is shifted to back line where this label is stored. So again testing of bit 0 of status register is done. This will be continued. The control will be in this loop only till that bit 0 becomes 1. When that is when keyboard is pressed and the data is ready in data in register, then this SIN bit is made 1, branch 0 becomes false, then control is not shifted back, it goes to next instruction here. What is the next instruction? Move data in, R1. Whatever pressed key character it was there in data in register, that is moved to R1. So in R1 keyboard character which was pressed, that is copied. So this is called as reading a character. So first action is over, read a character is over. Next instruction is test bit #1, status. So bit 1 in the status register that corresponds to SOUT, that is status information of display device. So if it is 0, then that indicates display device is not ready. Shift the control back to previous instruction. Again test bit 1. This checking goes on continued. So processor will be in a loop, that is it is polling, that is bit 1 of status register, that SOUT bit. When it becomes 1, that indicates that display device is ready. Branch 0 becomes false, then control will not be shifted back, it goes to next instruction. Move R1, data out. In R1 the pressed keyboard character was brought and this is sent to data out register where display unit is connected. Hence that character is displayed on the display device. So second action is over. So what is the command for this? Send character to display. Now to actions are done. Reading the keyboard character, then displaying that character. What is the third action? Now that character must be sent to buffer. It should be stored in the memory. So what is the next instruction after sending the character to display? Move R1 comma in bracket R0 plus. So this is post increment addressing mode kind of instruction. So this move instruction will copy the content of R1. Keyboard character is there which was pressed. That is sent to. This bracket indicates this is the address of memory location. So R0 was made as a pointer to buffer or memory. It was storing the first location address of the buffer or memory where line of characters is going to be stored. So in that R0 pointed first memory location, their keyboard pressed character is stored. Then R0, that memory location address, is incremented by 1 word size. Means it R0 now points to second memory location in the pointed buffer. So that next time when keyboard is pressed, that second character will be stored. When second character is over, when it is incremented, it points to third memory location and hence third character will be stored. So this is post increment kind of instruction. After storing R0 in R0 pointed memory, then R0 pointed memory location address, that R0 content is incremented by 1 word so that it can point to next word address. So next memory location address. Store character and advance pointer. That is the comment to this. So the next instruction is compare hash $0D, R1. So this is what is checking whether user has pressed new line character or enter button, yes or no. If it is not pressed, then branch not equal to 0 is true. Shift the control back to wait key label. Means again control continues here. Testing bit off, that is bit 0, that is keyboard status information is taken. Till it is ready, the processor will be in this loop. When keyboard is ready with the data, that keyboard character which is stored in data in is sent to R1. Then the bit 1 of status register is checked whether display device is ready or no. So if it is 0, that display device is not ready, processor will continue in this loop checking for the bit 1 of status register. When display device is ready, so branch equal S out bit will be 1, branch equal to 0 will become false. So it will not shift the control back here. It will go to next instruction. Pressed keyboard character will be sent to data out register. This will take the character to display device because display device is connected here. Next R1 is so keyboard character what is stored in R1, that is stored in buffer and that is second location now. After storing, the address in the R0 is incremented by 1 word address so that R0 points to next memory location. So again compare the keyboard pressed character by the user whether it is enter button, yes or no. So these steps will be done for all the character till user, for all the characters till user presses enter button. When user will have pressed enter button, so this becomes false, means branch not equal to 0 is false. So the control is not shifted back to read the character. So it goes to next line. So this is line feed character. So carriage return means carriage is returning back that hardware. Then it is positioned in the first place of next line. Both 0D and 0A are required to shift the cursor to next line first position. Right? After that, because the task of reading a line of characters, printing on the display unit, displaying on the display unit and storing them in buffer is over, because user has pressed new line, that is over. So the next instruction used is call process. Process is the name of subroutine, set of instructions which are needed to process the input line. That is the line of characters just now read. So call means there the that subroutine the control is shifted as to process the input line. That is what is the explanation for question number 7b. The question was, explain IO operations involving a keyboard and display device with a program that reads one line from keyboard, stores it in buffer and echoes it back to display. Asked for 10 marks. So in this we first explained 4 registers required, which are there in the IO interfaces of keyboard and display device. That is data in, data out, status and control registers. With that prior knowledge, we took the program, assembly language program, which does this task, for which it had to execute 3 actions: reading a keyboard character, then display it on the display device and store it in the memory buffer. So repeat this action for all the characters given by the user through keyboard till user presses enter button. Okay, and that completes the discussion of the solution for question number 7b, which is asked for 10 marks. That completes the discussion of question number 7, A for 10 marks and B for 10 marks, question number 7 for totally 20 marks. So till question number 7 I have discussed. Here onwards what question numbers are there in the question paper, that is question number 8, 9 and 10. The links of those videos which can answer question number 8, 9, 10 of model question paper set 1. The links I will have shared in the description box of this video. Please you can refer to them. Okay. That completes the discussion of model question paper set 1. So you can make better use of those videos. That completes the discussion of model question paper set 1. I hope you understood. Thank you.